Hello everyone, I am Chong Kim and I will present our team's project proposal. Our project is titled Combat Situation Recognition Model Using Sound Data. This is context for presentation. This presentation will cover problem definition, project necessary, previous studies, dataset, model selection, and division of labor. This graph shows the military drones market size from 2023 to 2032. As evident from the graph, the market size is gradually increasing. This suggests a continuous rise in the importance and utility of drone and robotics technology. Furthermore, military drones have made significant contributions in recent times. The following video explains crucial role of military drones in the ongoing Ukraine conflict. Let's watch the short video.
Предлагаем вам сдаться по одной простой причине. Нам нужен обменный фонд. Ежели вы не изъявите такого желания, мы вас...
However, these military drones mainly rely on visual data. In a war scenario, several factors can obstruct the acquisition of visual data. For instance, during the dark of night, visual data may not be accessible and various interferences can lead to untrustworthy visual data. Therefore, we propose utilizing auditory data to perceive and assess the surrounding situation instead of relying on visual information. By using sound data, it will enable robots to detect and interpret sounds, formulate strategies, and execute tasks in various situations. Such technology is expected to enhance the flexibility for robots in various situations, enabling them to operate effectively in wartime. On this slide, I will talk about the previous studies. There is little existing research about sound classification for military situations. While environmental sound classification is currently a topic of active research, distinguishing sounds is very challenging due to high levels of noise and the absence of patterns. As a result, the conventional approach involves extensive pre-processing and feature extraction for application of machine learning techniques. Hence, in recent times, there has been a growing trend in using deep learning methods. The dataset we are using is titled Natural and Artificial Occurrence Non-Verbal Sound Data, which was compiled with the purpose of developing artificial auditory intelligence. I will present two samples included in this dataset. The first is the sound of tanks moving during wartime. The next sample is the sound of armored vehicles in motion. In this dataset, there are about 45 pieces of nonverbal sound data, both natural and artificial. These data are categorized into 10 major groups. Now let's discuss how we use this dataset. Data with various conditions are useful for training a model to identify people on the battlefield, assess the nature of combat, and determine the type of weapon being used. Additionally, the inclusion of mixed sound data allows for more accurate assessment in actual combat situations. Furthermore, this dataset is well pre-processed for machine learning with about 30 seconds of context data captured before and after each sound. Let's consider the expected challenges and solutions for our project. First, in the actual battlefield, various noises are mixed, making it challenging to build a model that can accurately judge sound. To address this, we intentionally introduce background noise to artificially recreate an environment similar to battlefield. Second, context data may result in reduced model performance. For this problem, we will perform pre-processing to selectively trim unnecessary context data. Now let's discuss model selection. Traditional machine learning often requires manual extraction, demanding domain knowledge for data interpretation. Moreover, with various noises, extracting and analyzing features effectively can be challenging. Therefore, we select for deep learning models capable of automatic feature extraction. We are considering 4 deep learning models. RNN is a model primarily used when dealing with data that is time-dependent or exhibits sequential features. The sound data we aim to train is time-dependent, and we believe that information is generated through sequential relationships between the data. Therefore, we have selected RNN as our basic learning model. While conventional RNNs are effective in learning contextual dependencies, they face challenges when dealing with longer sequences such as vanishing gradient or exploding gradient. To address this, We have opted to incorporate LSTM as well. This helps mitigate potential learning disturbances and ensures a more robust training process for sound data. Additionally, we are considering 2D CNN recommended by the data provider. It has shown outstanding performance in image classification, and we believe that by transforming sound data into images, we can achieve significant improvement in our model's performance. Also, KNN will be applied to contrast the learning efficiency of traditional machine learning algorithms and other deep learning algorithms. In fact, the KNN algorithm is utilized in various domains such as image and video processing. In situations that are less complex than expected, it may be more suitable than deep learning algorithms. Finally, I will talk about the feature extracting method. For feature extracting, we plan to employ MER spectrum and MFCC. These methods are widely used in the field of sound classification. MER spectrum better reflects human auditory cognition, particularly being more sensitive to changes in lower frequencies. Also, it allows us to capture all three essential aspects of sound: time, frequency, and intensity. MFCC performs well in general situations due to low correlation between frequencies. This is the final slide of the presentation. I will provide a brief overview of the division of labor. Initially, we grouped the deep learning methods based on their relevance, creating one group for RNN and STM, and another for KNN and CNN. For the RNN LSTM group, the models will be developed by Hwang Go-seok-hwan, Lee Chang-yong, and Kim Chong-soo. For the KNN and CNN group, Lee Jae-hong, Im Soo-hyun, Jang Sung-min will be responsible for building the models. This division allows us to compare the different approaches effectively. Thank you for listening.